So for problem 5.51, you're asked, or you're given the information that each entry in a table of random digits has the probability of 0.1 of being a 0, and the digits are independent of each other. And you're asked, so that you're given that the probability of each digit is equal to 0.1, right? There's 10 digits and each has an equal probability, so it's 0.1. And the digits are independent. So we've got a binomial setting. You're asked in part A, what's the probability that a group of 5 digits from the table will contain at least one 5. So the probability that x will contain at least one 5, that's translated into greater than or equal to 1. Right, so the random variable here is you're letting x equal the number of 5s in a group. So that's the number of 5. So a success is getting a 5, right? So the probability of getting a 5 is equal to 1/10. So when you're asked for the probability of, and the language is at least one, what you can do for that kind of problem is translate that into, well, that's the same thing as 1 minus the probability of none. Okay, we talked about that in class. That's that complement way of solving a problem. So binomially, what that would look like, so the probability that x is greater than or equal to 1, and I'm going to take that approach. I'm going to say, well, that's the same as 1 minus the probability that x equals 0. And that's a binomial distribution, and x equals 0 is n is 5, right? A group of 5 digits. The probability of success of getting a 5 is 1, and then 0 is the interest point. And that value is 0.4095. Oops, sorry about that. So the conclusion is that there's a 40.95% chance that the table will contain at least one 5. All right, that the table entry will contain at least one 5. Part B asks a different question. So let me grab a different color ink here. B is asking what's the mean number of 5s in lines that are 40 digits long. So we have a binomial distribution, and you know what the mean of that distribution is, right? The mean is equal to NP. And let x equal the number of 5s. In this case, x is equal to the number of 5s. Actually, it's not all that important, but... So, what do we have here? N is 40, and we know what P is. P is the probability of getting a 5 is 0.1. So N is equal to 40, and P is equal to 0.1. So the mean is equal to 40 times 0.1 or 4. So you would expect on average that in a line of 40 digits long, you would get 4. Okay, so that's it for that problem.